Highness is representing DSM and he's industrial and architectural designer.
This is how we did it, and still happening. Take, make, waste, like in China. If you've ever been there, you see the polluted rivers. But also the river, I live in Maastricht, is also quite polluted. So you pollute, you disperse, you end at the chain unknown and untraceable. In fact, what you do, you throw stuff away, you disintegrate and you dematerialize. And this is how we do it now. It's better, but better means less bad. Take, make and reduce waste. We're conscious about waste and we now know that it's a valuable material. And there are all kinds of, standards which force you to make better products, to pollute less, like the end of life for vehicles, like the VIA standards in the electronics industries. The REACH, of course, important for material development. And this is the concept of cradle to cradle. Eliminate the concept of waste, rematerialize instead of dematerialize, and be good instead of less bad. And try to give something back. Don't take only. As already addressed, there are some principles, 3 main principles. Waste is food, and then in terms of 2 streams, technical materials which you can endlessly recycle, and biological degradable materials which you could use as a nutrient actually to restore soil. In general, you could say it's all about detoxification, using the right materials. And it's very nice, the concept is very nice, but to do it actually in reality is very difficult. And one of the big problems is how can you get control in the chain? The other second principle is use solar income. My students did some work on PV cells, and they came up with the result that only 0.5% in the world is actually now alternative energy. So there's still something to do. And in terms of cradle to cradle, the evaluation of products and the content, energy content, they say, well, it's not that important because it's free. It comes from the sun. It's true, but you have to convert it. So you need a lot of money to invest. And that will take a lot of time before it's really so far that we can say, okay, energy doesn't matter because it comes from the sun and we have invested in infrastructures that it's actually there. And then celebrate diversity, stimulating diversity, reinventing the city, urban farming, green roofs, diversity, of course, in people, respect different races, diversity in thoughts. But for me, the most important concept of cradle to cradle is the concept of eco-effectiveness. The concept that maybe we can do stuff and create stuff which are beneficial for the environment. So I came here this morning, left my bed at 4 o'clock, and I drove to the airport, I pollute. I flew in, I pollute. I came by train, we pollute. Maybe there comes a time that all these actions I did this day, that they are beneficial for the world. And that's a fantastic concept. And there are examples of that. So that was a small introduction. Now something about what I call a real cradle. If you want to tell something about product development, whether it's a bottle, a computer, a car, or a building, then you should have a thorough knowledge about the material transformation process. And here you see on the left the earth. We're raping daily in search of materials. And then all these steps in the chain to create from raw materials materials, and to create from materials products, and then distribute them in what I call the man-made, the artificial environment, which exist out of 2 important complementary systems, which are the movables and the real estate, the unmovables. They are complementary. They are complementary like if you want to sell cars, you need roads. If you want to sell mobile telephones, you need networks. So they're complementary system to keep things going. And you see that DSM, the company I work for, is quite upstream. And one important thing adding value, earning money, it's not only the goal of the process, but it's also very valuable. Money, everything stops. And I draw here a match. If I put it in a box, I can, and the box is completely sealed, I can have it there for thousands of years. So the lifetime can be thousands of years. When I open the box, I light a match, the use time is a second. While this pyramid, as long as the skin is buried, the use time can be thousands of years, and as soon as the pyramid is plundered, those heap of stones can be there another 1,000 years, but the function is gone. So thinking about longevity and about sustainability is very much dependent on what we do and how we treat products. In this chain, in this supply chain, in this material transformation process, in this knowledge chain, there's a particular moment, a peculiar moment, and that's that somebody's buying your stuff, or that the architect finds a client, or that the clients find someone to buy the house or to rent it, or that somebody actually bought this bottle. That's an important step. And why? Because up to that step in the chain, there's a relative control about the things we do. As soon as this is in the shop, on the shelf, then Kildeveld has lost control. And what is going to happen with this bottle, you don't know. And that's something you would like to have if you talk about cradle to cradle and closing loops. In this process, there's another important step, and that's where, in fact, it's very peculiar, and you don't think about it, but it's the place in the whole chain where an amorph material becomes shape. This bottle, this PET, these were grains, and the fact that those grains are transformed in this bottle is a very peculiar moment in the whole transformation process. And shape stores memory. This computer is not only a computer, but it's also the knowledge about making computers. So it's embedded knowledge. And geometry is life, and order requires energy. So what we need to define this interface is a program of demand. And the program of demand is like in nature, the DNA, how things get shape. And this moment I call the final interface. And why? Because in my opinion, this moment, that's the real cradle. Doing good or making shit starts there. And the cradle starts with design. Design is the interface between matter and market. And this is not a straight line. It's multimorph. It's from soup to geometry. It's bounding molecular change and specific generic mark-driven functional geometry. And sometimes, for instance, now we don't do that anymore. We had a big business with polypropylene, so they were used in bumpers. So we make material specifically for bumpers, -20, +70, you could paint it, good impact behavior, so a material tuned for a very specific application. While on the other hand, you can make, say, plates or rods or profiles which have more or less a shape, but can be in the table, it can be in the microphone, it can have many different functions. And if you look from thermodynamics, the first law, energy is never lost. Second law, that chaos increases. Then you see this particular moment, this cradle occurs almost by itself. We don't know where the oil is in the North Sea. We don't know where bauxite is in the jungle. It's dispersed and there's chaos. And we put a lot of energy in finding it and controlling it. And finally, we have defined that this bottle will be of PET. It will be delivered by BASF. It will have a wall thickness of 0.8. There will be a PE cap on it. And so you defined the whole process and the whole geometry. But then we do something strange, because then we start to distribute all these products again we've designed and made, and we lose control. And that's exactly what Cradle to Cradle wants to address, to close loops. And closing loops is easily said, but it's very difficult to do. This scheme, you see on the top, the post-industrial stuff, materials, and in the bottom you see the and on the top you see the post-consumer materials, and on the bottom you see the post-industrial flows. That's very complex. It's I give one example or some examples. At one, you try to reuse the bottle, or you try to take care of your car so that you can take it, use it longer. And then, of course, after using it up in a cascade system, then finally, for instance, if you talk about polypropylene for this bumper, you could imagine that the bumper is shredded and used again for a bumper, but that will be hardly the case. More likely is that the material of this bumper will be shredded and sold to China, where they make maybe a part of a seat or maybe a splash shield of a car. And you can go further in the chain where you depolymerize the material, take the polymers into monomers and create new material with the same value and properties as the virgin one. At the bottom you have the post-industrial recycling steps. They're of course much easier, because if I have an injection molding machine, the sprues and all the rest which is waste I can immediately bring in in the machine. It's working?
Is it out?
Battery's probably gone. Well, it doesn't matter, I take the other one. Is this? Yeah, it's working? Yeah. Okay. So that's easy to recycle post-industrial stuff. I also put the building there because although I own the building, I will never break it down myself. And then an important issue in cradle-to-cradle terms is how can you control biological nutrients that actually will restore soil? How will you get that back? And it's a very complex system. It's not linear, it's circular, it's parallel, it's sequential, it's very, very complex. And here you see, for instance, the complexity of the system. By the way, this disaster of British Petroleum also indicates what is actually happening with oil. More than 90% is burned as fuel, and less than 10% is used in the chemical industry. And we run out of oil. And due to this crisis, this man in his chair has a problem, because his pension funds invested in BP and the rates are going down. So he has a problem. While this company who provides these tubes to keep the oil together has a big business. And at the end of the chain, we have problems as well. This is 1 week of industrial products, consumer products, of Van Gansewinkel in Liège, in the south of Holland. And here you see these birds, this plastic ocean soup with all the rests of the process in the stomach. You're all familiar with the plastic soup, I guess. And although we live longer, in Europe at least, dilution was never the solution for pollution. And what you see is that pollution goes from local to global, and from visible to invisible, and from acute to chronic. And that's really a problem. So I would like to say that DSM, as a chemical industry, we are the #1 on the Dow Jones Chemical Industries Sustainability Index. And you could say we are the best in terms of sustainability in the chemical industry. What it actually means is that we pollute maybe less. And what it actually means is that we are more transparent about what we do. But we still pollute. So the next chapter is about design and plastics. And of course we have heroes, design heroes. And you can study your history and you can come up with all kinds of people. For me, Buckminster Fuller is an important guy in this process of, say, resources, energy use, ecological consciousness. Even 10 years before the Club of Rome, he made already a report where he addressing energy and materials in an ecological context. And who read the book about cradle to cradle, rethinking the way we make products? Some. Well, you should read it. There are many books to read, but that's one. And there, say, rethinking the way we make products, the issue of design is addressed. And then you could ask yourself, what is design and what do we mean by design? Because design is nowadays a bit, say, over the edge. Because design is associated with nice things. And I don't give a shit about nice things. I want to have good things. So Mr. Mandini says, for me, design is I'm on a quest to communicate through my objects and work in general. Well, that's like an artist. That's me. Mr. Brancy said, design is a grand cultural strategy with the ultimate aim of creating a better world to live in. Yeah, we hoped we can do that. And I hope that when I was, say, 30, that I could do that. Now I'm 65, and I have some big questions whether we are able, with technology, to create a better world. Anyway, I don't give up the hope. Mr. Irvin says, everything that's manufactured has been designed by somebody. Yeah, that's true. And in the context of cradle to cradle, Braungart and McDonough defines design as an attempt to fulfill human needs in an evolving technical and cultural context, many variables. I put myself in a row, I don't call myself a hero, but for me, design is transforming data into a product. And a product is everything you deliver to a market. It can be a service, can be virtual, can be physical. And of course, design is much, much more than decoration, styling, or aesthetics. It's supporting the continuous transformation of matter. And as already addressed in the previous speakers, that design in a circular economy is the end and the start of the chain. It's no use of saying you can recycle this bottle, the material of this bottle, if not somebody is actually doing it by making a design of used PET or used polyethylene. So, as MacDonald states very nicely, design as the first signal of human intention. What are the intentions? What are we making? For whom are we creating value? To fill my own pocket? Or what are we making? And from objects to objectives. I call this E4 design. Of course, the economy, the equity, and the ecology, but also embedment. So I put a lot of effort to come here and to talk, and you show these slides, but blah, 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 blah. We should do it. We should actually do it. And design is based on generic concept. That means that some people ask me, what do you think about cradle to cradle compared with the natural step? Or what do you think about this? Or what do you think about that? Well, there are many, many comparable generic solutions which are very old. And it looks like, you know, this whole sustainability movement is new, but it's already for ages, even in the Roman time. And design is using evolutionary technology. And it looks almost that it's a kind of autonomous process where we, as a society, create functions and geometries based on these singular human intentions. And if we don't do it, if I don't do it, someone else will do it. And you can almost predict the new iPod, what will be the functionality of the new iPod, just by thinking about evolving technologies. And when we design products, the impact of the concept you make is enormous. More than 80% of the concept you design is defining the environmental impact of the product. And maybe do we need a design police? This is a copy of a German magazine which is addressing the very issue of Geschmackfragen, of, say, aesthetics. And do we have to accept all the stuff coming in our country, which you could question yourself, where the hell do we need it for? And the effect of time on delivered usage and functionality. This match, if you light it, costs much more energy to make than it creates when you light it. And there are electronic equipments which has so many processes like rare earths and so many particular steps to create it that even if you leave them for 5 years in your lighter, they will still have more embedded energy than using in this 5 years. While on the other hand, there are buildings, for instance, which accumulate energy in their lifetime, but can be very efficient due to their longevity. Types of products. In fact, whether it's a house, whether it's a bottle, whether it's a computer, there are only 3 types of products. There are components, monolithic, monomaterial, this white beaker. There are components, monolithic, multi-material. That means that if I melt this beaker, it will never become a white plastic. It will be a pink plastic. And if it's the inside white is polystyrene and the outside red is polystyrene, I can melt it and I have polystyrene. But if the outside is, for instance, a polyurethane, which you wouldn't do, but as an example, then you make an incompatible material combination which you can't reuse anymore. And then, of course, there are assemblies like cars, like computers, like this coffee machine. And assemblies can be monomaterial or they can be multi-material. And when the monomaterials or when the multi-materials are compatible, you can design them in a different way than when they are incompatible. So there are many, many variants and aspects to allow eco-design. I won't address them all. We give one afternoon college at the university, and there actually the students tear products apart and learn by well, what they see, what they analyze. I will address some of the aspects. So choosing the right materials, that's already a hell of a job. And as Mr. McDonald is stating here in the line under, you don't have to read it, but it states that the role of designer and the architect is nowadays limited by decision making about materials. And so or the manufacturer or the client chooses materials. And I think it's important that designers and architects take more responsibility about the materials in their products. Intended use and use time, very important in defining and choosing materials. Where will it be used for and how long will it be used, and are we able to get it back? So this nice EcoVision television of Philips is one of the greenest television currently in the world, but you can't eat it. And it's nice to have this, but if you don't take care that at the end of the chain it's taken back and taken apart by Philips, then you miss the point. And the same in terms of cradle to cradle, the approach to PVC. Well, their approach is to ban all PVC, but PVC is a very nice inert material. And you have problems if you burn it. And you have problems with softeners if you have your soft PVC. So how do you deal with materials in relation with the use and the use time? Is there something like sustainable styling? Can we make products which last longer because they look nice? Can we make buildings which last longer because they're well designed? You can do that by, for instance, creating open systems, like is done in automotive. In car manufacture, the French talk about la structure et la robe, and they make a structure of the car for 15 years with all the investment, and then they just change every 5 years the outside. So that's a way of creating well, systems which last longer and which are flexible. Standardization is an important way of creating better products and making sustainable designs. If your computer, the graphic card is gone or defect, then you don't have to throw away the computer, you just plug in a new card. And the European Commission commanded that all suppliers of mobile telephones should use the same supplied plug, the same charger. So that will save a lot of material and chargers in your drawer. And can you make it simpler? Can you eliminate interfaces? On the right side you see a seat with more than 100 different materials, with 10 electric motors, with foams and leather. Very complex and almost hard to not to recycle. And on the left you see this monomaterial seat. And of course, they're completely different in comfort, but maybe there's some solution in between. And then design for repair, of course. An example of a packaging, we supply resins for AXO, and those resins are VOC free, so they don't emit all kinds of stuff. They are monomaterial, they are nestable, they're recycled with polypropylene labels and used recycled polypropylene. So that's a nice example of a product, a packaging product, which also is multifunctional. I'm sorry, I was a bit too quick. In the south of Holland, we have a company of Mitsubishi who's closing down the factory. There's a huge investment in machines, in stamps. And why not try to reuse a factory? Why not try to reuse this factory, for instance, for building? This actually, the idea was initiated in 1971 in Chile, where there was, due to this crisis, this political crisis, no engines came anymore in the country from France. So students were looking how they could convert this plant in making building components. Or IBM, with 30% waste of their wafers, they could now scrape it off and use this rest material to produce PV cells. And of course, as designers, as architects, try to stimulate the reuse of material. And there are many, many different ways in building and in product designs. And try to make your customer a hero. For us as a DSM, it's better to have our customer, our client, saying that, oh, you have beautiful material, that he feels a hero, than you do it yourself. Make your customer a hero. Okay, I come to the last part of the content before the examples. Plastics. Plastics are very flexible materials with, well, they can have all kinds of properties, but a main property is that they can be fossil-based, so from oil, or they can be from renewable resources. You can't do that with steel. And plastics, in terms of cradle to cradle, can have two phases. There can be a technical nutrient or biological nutrient. And that's, of course, a very, particular property. And talking about renewable materials, bioplastics are plastics whose components come from renewable resources. And they can be durable or degradable. Also, bio-based plastics you need to recycle. Because a lot of people think, well, it's renewable, so at the end of the chain we can burn them and throw them away, because at the start we can grow new plants, so we don't need to recycle. Yes, you need to recycle them as well. Also, bioplastics has nothing to do with the concept of biodegradable. Different concepts. And we are, as DSM, involved in bioplastics, second generation, trying not to use the food. Why? Because they lead to cleaner processes. You save on greenhouse gas savings, less energy, and you can make complete new polymers. There are drawbacks. You need water, which is scarce. You need phosphates, which is even more scarce. Maybe we run out quicker out of phosphates than out of oil. You need land. You create monoculture. And how can you close the cycles? So bio-based materials is not in itself that good. And then, of course, you have biodegradable plastics. And biodegradable plastics are plastic that decompose in a natural environment and considered safe for those biological cycles. But this polyethylene cap, I can make this biodegradable by just adding some potato powder. Or I can make very, very durable materials from a bio-based feedstock. To illustrate this, I have this pen, and I throw this pen in the grass, and after half a year the pen is gone and the grass around it is also gone. Well, that's not what you want. Or I take this pen and I throw it in the grass, after half a year the pen is gone and the grass is still there. Yeah, that's good. But we can do better. You throw the pen in the grass, after half a year the pen is gone and the grass is 10 times higher. And that's an example of eco-effectiveness. And actually there are materials which do that. So, coming to the end of this chapter, as a designer and as architects, you see that the task of designing is becoming more and more complex due to all the parameters you have to involve, the choice of materials, the energy consumption, emissions, toxicity, risk potential of the things you do. And we at DSM have a life cycle analysis center, and to actually analyze what the effect of the products and the materials we make is on the environment. And we now come up with a whole new range of materials which we call Eco Plus. In terms of cradle to cradle, they say we don't care about life cycle analysis. We want to talk about use cycle analysis. And we don't want to reduce the footprint. We want to create a beneficial, larger footprint. And in the framework of cradle to cradle, there are a whole bunch of assessment tools to evaluate the effect of a product and your material on the environment, toxicity, recycling possibilities. We work now for 5 years with EPEA, and EPEA has helped us in developing 20 new materials which are cradle to cradle certified. So I come to the last part, some examples. These examples are not necessarily only from DSM, and there are also some old stuff, but they refer to sustainability in general. So this card is Ford U model. It's made out of bio-based materials, bio-based plastics, among soya for the tires. And this is a nice example because the tire is a consumption product. If you drive, you wear it out. So this powder which you leave on the road could harm your environment. So you can imagine that you leave stuff which is beneficial for the environment. By the way, it's also nothing new because Ford in the wartime already made the car out of soybean oil. Desso is a Dutch company who is involved in carpets. We supply them with our nylons, with our polyamide 6. And Desso has developed, due to this cradle-to-cradle philosophy, some new products. One is Desso Airmaster, which captures dust, and some models and products which use recycled nylon. Or Philips. Philips has developed a green vacuum cleaner with recycled materials, and also adapted the concept of standardization. So the engine, which doesn't deteriorate that much, can be taken out and can be reused. These are old concepts for building, for detachable units in cardboard. So in fact using a biodegradable material for a building system. Talking about designing products with a second life, the Wobo bottle, designed by John Harbraken in the 60s, is the first attempt to create a packaging which could have a second life. So it's not only a bottle for beer, but it's also a brick to build. And in 1973, I designed this building using oil drums, these bottles, and VW components to create an office space for our architecture office. And then in 2010, you see that more or less the same approach by Miniwis in Taipei. They use polyethylene bottles to create building components. And as this beer bottle was produced with a second function in mind, Here, there's a complete new bottle designed as a facade system, but on the spot. So they actually produce these bottles on the site and use the shredded polyethylene to the PET to make new bottles. So that's a very step forward. Another example of using waste plastic for low-cost housing, where you could use all these plastic dumped in cities like Bombay to transform them in, for instance, roof elements. And in Holland we have the company Compain, who is very active in gardening, and they developed this green wall system they call Wonderwall, and it's really a wonder wall because it works tremendously good. It has its own irrigation system, and it can be used indoor and outdoor, and it really cleans the air due to the specific plants they choose. And this is an example for me as designer at DSM. I showed in the first slides that we are, say, left upstream in the chain. How can you get control downstream in the chain with other partners to do what you want to close loops? And this was an attempt to create a kind of elevated floor system in nylon, where we supply the materials, where Legrand, which is a big producer of electronic equipment, produces this part, and where Desso puts on the carpet tiles, and we have a Ganzenwinkel, who's say at the end of the chain, is collecting this stuff, and we could use our processes to regenerate the material. New business models. That's very difficult to achieve, especially for us as DSM being upstream. How can you create control downstream that actually stuff is coming back? And how could we, for instance, say, you don't have to buy this PET, you can hire it. And you can hire it for very good conditions, unless, but you have to take care that the material is coming back to me. Well, Philips is thinking along the same way of light for hire or seats for hire. And it's an old concept of renting stuff. This is an example of, which is also mentioned in the book Cradle to Cradle, Remaking the Way We Things Make Products. It's a development we did 20 years ago to depolymerize nylon into its virgin material and use the carpets which are, say, collected, cleaned, and then depolymerized to make new yarn, and use that yarn to make new carpets. And this nylon PA6, if you depolymerize it, is an example of a technical material which you can really use endlessly. Because, I come back to that on another time, not all materials you can easily melt and then reform again, because you get a degradation of the properties. We noticed that due to this cradle-to-cradle movement, so to speak, and our customers who are working according to cradle-to-cradle philosophy, we have a huge business in, for instance, this office seats. So we supply Herman Miller and Giroflex and Steelcase with our materials, which are cradle-to-cradle certified, and they make nice office chairs out of it. And coatings over plastic. Normally you wouldn't do that. But if you use regenerated polypropylene, you might have streaks in it, you might have color differences. And now you can use these materials by just spraying a nice coating over it. That yarn to make new carpets. And this nylon PA6, if you depolymerize it, is an example of a technical material which you can really use endlessly. Because, I come back to that on another time, not all materials you can easily melt and then reform again, because you get a degradation of the properties. We noticed that due to this cradle-to-cradle movement, so to speak, and our customers who are working according to cradle-to-cradle philosophy, we have a huge business in, for instance, this office seats. So we supply Herman Miller and Giroflex and Steelcase with our materials, which are cradle-to-cradle certified, and they make nice office chairs out of it. And coatings over plastic. Normally you wouldn't do that. But if you use regenerated polypropylene, you might have streaks in it, you might have color differences. And now you can use these materials by just spraying a nice coating over it. This is an example of some of the work we do as advisors for the automotive industry. This is an automotive seat made out of two materials, a soft liner with foam substituting springs, and a kind of biomimicry where you have tensegrity, where you have bone structures and tension muscle type of construction way to spread loads. And along the same line, trying to eliminate foams, because foams are very hard to recycle and contain all kinds of nasty stuff. This is an example of material Ecopax, just the name, but it's a polyamide 4, which is made from castor oil, which is the bio-based feedstock. And it's an example of how nature provides us with stuff which allows us to make better material, with higher performances, less moisture absorption, better chemical resistance. And another material is Ironitel. It's a thermoplastic elastomer, which is used to substitute PVC in cables. And by the way, it's also used in the iPods. CO2 is a problem, but CO2 is also feedstock. You can use CO2 to make materials. And this material I said about this pen, polyhydroxyalkanoate, you can make it from CO2, and it's a material which is biodegradable, aerobic, anaerobic, and already at 30 degrees. Biomimicry. We develop coatings for PV modules which increase the efficiency of the modules. And this development is based on the moth's eye, so bio-inspired. And that's in fact where we see as DSM, because we have life sciences, medicines, food and material sciences, where we see innovation by blending material and life sciences, where biomimicry as a driver for process and geometry, and especially for processes. So learn from nature how they make things and try to copy that. So to end this presentation, maybe we should shoot some pigs to make a better world. Sustainable business is not expensive, but unsustainable business is too cheap. And as long as we keep throwing stuff away over the fence and somebody else has to take care of it, then of course it's quite cheap. So stop privatizing profit and socializing costs. That's what I would like to say. Thank you for your attention. I have a small ceremony to end this presentation, because we as DSM, we support all kinds of educations. I said already they paid me to be here, and it only costs money, it doesn't bring anything. I will spread some cards, so if you have some business for us, nice. But I would like to take this opportunity to hand over to Heidi a book we supported and developed, which is called Cradle for Kids, and describes more or less what I presented here, but then in a way that kids can understand it. Heidi, for you.
Thank you very much. I'm so happy to give this book.